Alright guys, welcome back to part 3 of making a Dandelion clock in Maya. Okay, so far we have covered how to model this Dandelion, how to give it details by sculpting it in Zbrush, and how to add fur to the seed. So right now we have the stem, which is rigged by these joints using an IK handle to animate. We have the center bud that is parented to the last joint of the of this rig, so that is following the stem. And right now we will take a look at this how we do the simulation, which you can see over here. I've actually cached it down so that you can preview the animation. Okay, so the basic idea of this is to firstly we need to plant the seeds down on this bud, and they have to face the normals of the surface, which means they have to go like 90 degrees out from the surface that they are planted to. And of course we don't want them to be stuck on the bud forever, so from on creation they are going to be planted on the bud. Okay, but after creation we want the seeds to actually be able to leave the flower, so we are going to achieve that using goals and particles, of course. So let's begin. So firstly, I did not actually use the bud as the emitter for the all these seeds particles. I actually use another spear that's hidden right inside the mesh. Okay, I call it the bud seed bed. So it's actually a spear. Okay, let me duplicate it and drag it out so that you can see it. Okay, unlock. Okay, I'm going to drag it out to the side. Okay, so this is the seed bed that I'm using. Okay, it has certain parts removed so that we won't have seeds coming downwards where the leaves are. Okay, so we have and it's a little bit smaller than the bud so that the seeds can go into the surface. Alright, so make sure when you do this, you delete history before using it. Okay, so this is for your seed bed. So right now we want to have the particles come out of the surface from here. So to do that, we go under Dynamics and we go to Particle, Emit from Object. Okay, we want it to be a surface emitter. Okay, you can set up the rate to be quite high because we just need the particles to stay, and we don't want to wait for the simulation to go up to 100 frames in order to reach our particle count. And we want to take the speed down to 0 because we don't want the particles to leave the surface. Okay, and after that just click you also need to check the need parent UVs, because we are going to use the UVs here to plant the seeds, so you will go along the UVs. So make sure if you are doing your own spear, you could just give it a very simple some UVs like the spherical mapping or just automatic mapping. They will work. Okay, so let's come back to Dynamics. Okay, click Create. Okay, at the start we will see a lot of particles. Okay, they will come out of the surface. Okay, but that's not what we want. We want a limit to the number of seeds that we have on one flower. And what I found working for me is about 130 seeds. So you could just find your own number. So let me select the particle. Okay, we have a particle shape node which we will control. Okay, under max count I will set it to something like 128. Right, so let's play it again. Okay, we see that we only have the required number of particles. So the next thing would be to instance our seed over here. Okay, So remember that we have our seed, which has a seed cap that is not shown, and a fur feedback node which is inside. Okay, so make sure you keep them in local space, which is essentially in world space. Okay, so if you want some variation, you could create other groups that has the different looking seeds, maybe some variation. But for this shot, I didn't actually use it because after you motion blur it, it doesn't really matter that much. So I will just be using one group. Okay, I'll just show you how to do it with one type of seed. So to do that, we'll select this, select the particle, go to particle, and we'll click instancer replacement. Okay, so right now when you play it, it's going to grow out of the particles are going to grow out of the surface, and they're all going to point towards the same direction which you have over at on the origin of the seed. Okay, so the next step would be to plant the seeds according to the normal. Okay, to do that, we will need to come back to particle. Okay, we will need to make the surface a goal for the particle, so that we have access to the normal values of this surface. So to do that, we will click. We will firstly have to select the particle, and then we'll select the seed bed. Go to particles, goal, and just click goal. Okay. So right now, if you play it, it's actually going to bounce and be attracted to the surface. Okay. So right now, if you take a look at particle, and if you go down to goal weights and objects, you're going to see several new things that pop up that weren't there in the beginning. Okay, there's going to be a goal weight 0 pp and goal world normal 0 pp. We will be using this two to for our simulation. So create this and this. So right now, what we essentially want to do is to have the aim direction pointing towards the normal of the seeds. Alright, so we will come under, this is under instancer, aim direction. Okay, we'll select go world normal 0 pp. Okay, there are a couple of other things that we need to set up before this works. Okay, one being the we will need the goal U and goal V, so that when we assign we will assign our parent U and V values to the goal, so that they will grow out of the UVs according to the normal of the particular UV that they are at. So to do that, we will come under add dynamic attributes. We will come under particle. Okay, so you will find go U and go V, click OK, and we will add some creation expression. Okay, so what we want to do is, okay, particle shape 2 dot goal U is equal to particle shape 2 dot parent U, and repeat for V. Okay, particle shape 2 dot parent V. Okay, once you do that, click create. Okay, right now let's take a look. Okay, it's coming out of the surface according to the normals, like this, and it's it's facing out in the direction that we want. Okay, this is great now. Okay, the next step will be actually to let it be able to leave the surface, because right now it's stuck to the surface and it doesn't react to anything. So that's when the where the goal weight comes in. Okay, at the start of the of this simulation, we want the weight to be 1 because we want it to get stuck on the butt. But as you play it, we want it to be able to leave the surface. So before we do that, we can actually initialize the state of the particles to look like this, so that we can proceed to actually use the rotation values and make it rotate in a certain direction later on, instead of having them face the normals all the time. So to do that, okay, we will select the particle, go to solvers, initial state, set for selected. So when you rewind, okay, make sure also make sure that you are playing every frame for the simulation to play back correctly. Okay, when you rewind, you will see that the particles doesn't go away, they stay. Okay, so at this point we can actually delete away the emitter because we don't have to emit particles anymore. We can come to expression editor. Okay, we can find the expression that we wrote. We can either comment it away like this, or we can just delete it totally. Okay, we can delete this totally and it will still work because we have already initialized the particles to be on the surface. Okay, so right now what we want to do is to have the particles be able to leave the surface. Okay, we will be using go weight 0 pp. So let's come back to the expression editor. Okay, we can access this by going to go weight 0 pp and do a creation expression. Okay, at the start, during creation, we want it to be 1, so that it's on the surface. Okay, so click create. And as for runtime before dynamics, okay, we want to set this to be actually 0.01. Okay, so that the particles doesn't actually leave the surface totally, as in if it was 0, it would have floated away. And 0.01 actually allows you to use fields to actually suck the seeds, the particles, away from one end to the other. So we'll set it to 0.01. Click create. Okay, let's take a look. Actually, there shouldn't be any change. It should still be stuck to the butt. Okay, so at this point, okay, we would need to fake that the seeds are actually getting blown by the wind. So we want to rotate the seeds slowly towards the direction that the so-called wind is blowing. So let's say for my original one, it's blowing towards the Z direction, as you can see here. Let me bring it up. Okay, so this is the Z direction. It's leaving towards the Z direction. So what I did was to have the seeds slowly point towards the Z direction. So as the simulation plays, they are slowly pointing towards the Z direction. And this is actually a fake illusion of getting blown by the wind. Okay, so to do that, we would need an extra attribute in our particle. Okay, so go to select your particle, come back here. Okay, we will have to create a new dynamic attribute. Okay, let's call it aim CTR, aim control. Okay, it has to be a vector and it has to be a per particle attribute. Okay, click OK. Okay, so it appears right here. Okay, let's go back to runtime expression before dynamics. Okay, what we want to do is, when the frame is 0, it should face the normal. Okay, so we need to get the values of the normal for every particle. So okay, I have actually previously already written this, so let's take a look. Okay, if frame is equal to 0, okay, we have this vector called current aim, okay, which will store the current normal direction of every particle. okay, it will be equal to the particles go over normal 0 pp, and then we will assign this value to the particles aim control. Okay, so let's paste this over to our demo particle. Okay, click edit. Okay, right now we have to come back to the particle shape node. You have to scroll up. Okay, we have to change this from go over normal 0 pp to aim control, so that it will take values from aim control. Okay, we will have to replay it. So at frame 0, it's facing the normal. Okay, if you play it, it should still face the normal, because we haven't done anything to our aim control. Okay, so let's continue the next set of code. Okay, from here onwards, we want to make the aim control slowly points towards Z. Okay, let me copy this and put it over here first. Okay, so let's go through the code. Okay, the current aim will again be the aim control. Okay, so let's say we are at frame 13. So at frame 13 we have the aim control has a current aim value that we will store it here. Okay, we will have a divisor which will store a value that decreases as the time goes by. So let's say we are at frame 13 right now, so 1000 divided by 13 plus 1 will be equal to this divisor. So let's say you are at frame 100. Okay, 1000 divided by 100 plus 1 is obviously going to be smaller. So as the frame as the animation plays, this divisor will become smaller and smaller. Okay, the reason why we want to do that is we want to have the seed get blown faster at the start, but gradually decreases as the animation plays, so it doesn't turn towards Z that fast when it plays to let's say a frame 100. Okay, so right now we'll store a vector called the difference, which will be, for me, for the animation here, is going to be towards the Z direction. So it will be 1 minus the current aim dot Z divided by the divisor. So this will change at every frame. So at every frame, the difference will get smaller and smaller. Okay, so finally, when you we will want to give this value back to the aim control. Okay, the particles aim control. So the particles aim control will have its original X and Y, but for the Z, it will add this small little difference. So let's say we're at frame 20. Okay, it will be the original Z, which is the normal value, plus the value that is supposed to increase by towards Z. So at frame 20, you have okay, let's take a look at these. Okay, at frame 20, some of these are already very much pointing towards X, but some of them are still not pointing, because this is a per particle attribute, so they all have their own values. So as the time goes by, let's say frame 70, okay, the initial seeds that are blown away are pretty much turning all the way towards Z already, because this is increasing but at a falling rate. So this is essentially what this part of the code does. It makes the aim control slowly point towards Z. Alright, so if we play back the final, okay, it's going to leave the surface. So right now, okay, let's test whether our values here work. So we have to change it to 2. Okay, edit. Okay, so you will see that it's slowly pointing towards Z. Okay, I would like to make a correction that it is pointing towards Z at an increasing rate, not at a decreasing rate. So at the start it's actually pointing faster, and you can see that at the end of the simulation it's pretty much slowing down. Okay, so how do we make it leave the surface? We'll just use a fill. Okay, for me I use the volume axis fill. You could pretty much use any other fill, provided that they have a maximum distance. So I'm going to show you how I did it. Okay, we first select the particle, go to fields, let's go to volume axis, click create. It will show up on the origin. Okay, we will translate it towards the flower. Okay, we want to actually use the we want to make this a cube. Okay, no, actually we want to use a spear, because it's able to suck from this point all the way to this point without starting from cutting it like you can see here. Okay, let me show you. Okay, if we place it, if we use a cube, it will be sucking more seeds at the start. Okay, but if you use a spear, it will be sucking less seeds from the start and then more seeds later on. Okay, you can feel free to scale this up so that it's sucking more seeds at one time. Okay, make sure it's bigger than your butt, of course, so that you can suck all the way to the other side. Alright, now let's change some of the values here. We will not be using away from center. We will be using a long axis. Okay, so you will be going towards the Z direction, which I will put here. Okay, this is X, Y, Z, and the direction speed I have a value of 10, so that is pushing it towards the Z direction. Okay, I have a bit of turbulence. Okay, this one you can just find a value that works for you. I use something like 1. Okay, and that should be ready to go. Okay, what you would do is to animate this fill going towards the negative Z direction. So I will click Shift W to set a key on 0, and perhaps on 50 it's going to suck all the seeds, and Shift W again, and I will just move it here. Okay, let's see what we have here. Play. Okay, it's sucking the seeds towards the right. Okay, so as an additional step, I have one more volume axis fill that I have here. Okay, which is essentially the same thing. Okay, it's except that this is a cube, and what this does is just to add turbulence. So it doesn't have anything in along axis, direction, speed, and all that. It only has turbulence. So it helps the simulation in that it disperses the seed a little bit better, instead of having them stream towards one direction. So you can actually see it from the top. It's more dispersed in if you add a second fill. Okay, so now that we have this simulation going good, we can move on to looking at how to actually fake the seeds that are spinning. Okay, for me, because we have actually used the aim direction attribute in the particle, we can't actually use this rotation option again. Okay, so what I did was actually just to spin the original seed that's in the at the origin. Okay, so what I did was to add a expression in the rotation, so that as the time goes by. Okay, let's take a look. Okay, seed group 1 dot rotate x. Okay, as the time goes by, it will have a you add a random number between 1 and 20 in the X rotation. So let's say I play. Okay, this thing is going to rotate X is going to increase. So it gives it every seed is going to rotate the same way. Okay, but what this does is it gives you the false illusion of it spinning away in the wind. And when you motion blur it, you can't actually see whether whether they are spinning the same or not. Okay, so you could of course use other solutions. This is my solution for this shot. Okay, so in the next part I will show you the lighting and of course the post-production.